Hello guys, welcome back to Math Zone African Motives. We are still on our mathematics for grade 10. And this is an important session that we're going to have on the numbers, talking about our number system under the algebraic expression as a head topic, then the subheading working on the number system. So on the number system, there is a presentation of numbers that you're supposed to know and also to understand. Remember, we talked about numbers. So this time it's a continuation. All right. They'll ask you to represent numbers or a set of numbers on a number line. All right. This is a set. So the set, it reads in different ways. All right. Like here, it's X is such that. All right. So here, X is such that. All right. How is this X referred to? This X, okay? Reading from this X, it is greater than -1, but the same X is less than 12. So the X is bigger than -1, but the same X is supposed to be less than 12, but it does not end there. The same X that we're talking about is an element of integers, the Z, indicating integers. All right, so you have to know R indicating what? The real numbers, and representing the natural numbers. If it is given as NO, that is whole numbers that you're talking about. So you need to know each and every presentation. So remember, a number line is just a presentation from our 0 point. On the left side, we go to the negative. To the right is the positive. So this is just like -1 to the negative side, -1, -2, -3, -4, to the side of the right. That's +1, +3, +2, +3, +4, and so on and so on. So these are the values that are on your number line. From the 0 point going to the right, positive. From the 0 going to the left, negative. So these are negative, these are positive. All right, so as if that's not enough, of which it's not enough, because we have a simplification that is going to happen. And what is the simplification? What is the presentation? Represent the following set on a number line. Let us start with the first question. All right, I'm going to explain this and talk about how do we present this one. All right, so given the set of values of X such that it is taken, our X is greater than -1, but the same X is less than 12. And this X is actually an element of Z. So the Z there, like I said, it represents what? Integers, all right? Remember, integers, what are we talking about when we are dealing with the integers? We are talking about positive or negative whole numbers. These are integers. These are positive or negative whole numbers. And on the whole number and on the integers, as long as you're talking about positive or negative whole numbers, it means the 0 is also involved. 0 is involved. All right. So now talking about our number line. If we were to take our values, we are going to take our values because they are integers and we are given in between. Thus we can take, let us just say we've got something of this nature. All right. Let's say we've got something of this nature. All right. -1 is not part of our solution because X is greater than 1. If there is an equal to, it means -1 is involved. But in this case, -1 is not. So on your presentation, if you are to indicate maybe just to say this is -1, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. -1 is not part of our solution. Our solution is in between, yes, between these values, but -1 is not part of the solution. Also, 12 is not part of the solution because X is greater than, it is bigger than -1. But the same X is less than 12. So you indicate from 0 because 1 is not there. And the whole numbers, the positive or negative whole numbers, we said 0 is part of integers. So we're going to indicate from 0, that's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Why not indicating 12? Because our x is less than 12. Take note, our x is less than 12. So it's not going to be involved. We are not going to talk about this x. It's not there. Are we together? X is not there. Okay? I mean, the 12 is not there. So that is how we could have presented the first one, which is the same thing. All right, let's see number 2. This is ARA. Remember, ARA, we are talking about real numbers. Real numbers, these are all of the numbers that we can, all of the numbers that you can just think about. Remember, guys, on our introduction. So they're saying x is greater than or equal to -4, meaning to say -4 is involved, is part of the solution. And like I said, real numbers, we're talking about both numbers which are rational and irrational numbers. So we talk about any number that you can think of, any number that you can just think about, any number that you can just think of, any number that you, any number that you can just think about. So if this is -4, which values are greater than -4 or bigger than -4? Greater than, we're talking about values such as -3, -2, -1, 0, 1, 2, 3, 4, and so on. So they are up to infinity. They do not end. Real numbers, they are up to infinity. They do not end. All these real numbers that you're given, except for the part that you've been given that is limited. But this one is not limited. All right. So meaning to say our values, they are going to be taken from +4. All right. They're going to be -4. I mean, going to the right. These are the values that are greater than, and the arrow is to show that these values are up to infinity. They do not end. All right. They're up to infinity. They do not end. They do not end. So also these are real numbers, meaning to say 4.5 is there. Minus, maybe it's 7 and 7.3, maybe it's 8, maybe it's 8 and 1/9. As long as it's a number, it's there. As long as it's a simplified number that you can have. The square root of the real numbers, guys. Real numbers, we're talking about anything. It can be square root of 9, the square root of 11, any number. All right. That's why there's no need for us to indicate the dots to say, because they are not whole numbers or integers. On that part, we were indicating exactly the numbers, not all of the numbers, but because we are talking about the integers, and integers, it must be positive or negative. So it must be taken from a certain point to a certain point and indicating those numbers, all right? So, but for real numbers, it's every number is involved. So you don't need to worry on that type of a question, all right? So that is it. Number 3 is the same. On this one, I want you to see on this one, because our x is real numbers taken from -3 up to +1, and x is greater than or equal to. So instead of what we did on number 1 like this, all right, I want you to see the difference that is there on number 1 and number 3. We are going to start at -3, which is fine. -3, -2, -1, 0, 1, like this. All right, this is what we're supposed to have in actual sense. But this time, instead of us indicating like previously, say -3, -2, -1, 0, and 1 is not involved. Instead of us doing this, because this is wrong, we are not going to do that, because the x that we're talking about is a real number. And any real number that we're talking about, guys, if we're talking about real numbers, we're talking about all rational and irrational numbers put together. So meaning to say also -3.5, also if there is 0.5, is there 0.1, is there. So you're not going to indicate these dots like on top of the numbers, no, because these are real numbers. So you're talking about every number that can be part of your set. As long it's a number, it's a decimal, it's a fraction, it's a whole number, all those numbers are real numbers, all right? So you indicate as that part of an arrow to say with the numbers, but when it is in between like this, you take a circle at 3, because there's an equal to a 3, you shared the circle. At 1, x is less than 1, x is not equal to 1. Because 1 is not involved there, you indicate a circle that is not shaded. Then you join, because these values are found in between. So you're going to join like this. This is what you do if they are real numbers, because you are saying my values they are in within, but 1 is not part of these numbers. -3 is part of these numbers, all right? And I'm taking every number there, whether it's a decimal, whether it's a fraction. But if I indicate like this now, I'm now indicating, what am I indicating? These are integers. It's on a condition now where I'm selecting only integers. So it's wrong for us to do it like that because these are real numbers, okay? So I hope now you understand this part. I just hope you're gonna try to work as much questions as possible. So for all these real numbers, you just take direct. If x is less than 2, like on this part on number 4, they are saying x is less than 2. So it means 2 is not part of our solution. Which values are less than 2? All these values to this side, they are less than. So you indicate with an arrow the values that are what? On the left side, which are less than 2. All right, because they are real numbers. So it can be a decimal, it can be a fraction, it can be a whole number. As long as it's a number, it can be involved in part of a set. So this is the idea that you have even on this one. Just go to 4.5, indicate an arrow to the right, all right? But now let's check this one. On number 7, we are given that x is less than or equal to 7, meaning to say 7 is part of our solution. X is less than or equal to 7. And this x that we're talking about is an integer, the z for integer. All right. So if it is like this now, because the integers that we have, guys, there are so many. There are so many integers that we are going to have. But because we are talking, guys, I want you to be careful. Please be careful. Please be careful on this part. What is important is that the x is an element of integers. And there is, guys, the integers that are less than 7, there are so many. Talk about 6, 5, 4, and so on. But you're talking about integers. So if you indicate like the previous case to say, all right, this is less than or equal to, then you say, because there's less than or equal to, I'm going to put what? A circle that is not shaded like this. I indicate an arrow like this. This is now wrong. Why? Because by indicating the arrow like this, you are indicating as any number. You're saying 6,5 can be taken. You are saying 5,2 can be taken. You are saying 4 can be taken. Because you just indicated that all numbers that are that side, as long as it's a number on that side, it can be taken, of which is going to be wrong. Why am I saying so? All right. It is because here we are given that this x that you're talking about, it's an integer. So at least what you do is that you indicate integers that are there that are less than 7, all right? That are less than 7, of which there's an equal to show that 7 is also involved. So we're going to start at 7. Because they are integers, which is the next integer, less than 7, we talk about 6, 5, 4, 3, 2, 1, 0, -1. All these, because integers, guys, we're talking about positive or negative or numbers, all right? So instead of us doing, because they're not going to end, they are up to infinity, these integers. But because I have indicated this one, this one, this one, this one, these circles on top of integers, it shows the examiner that the numbers here are integers. So I'm just going to show, because they are up to infinity, they do not end. All these integers, there's going to be -2, -3, -4, -5, -6. So I'm just going to indicate with an arrow to show, all right, these values, they are not going to end. So I'm just going to indicate with an arrow like this. All right. So to indicate an arrow at 7 like this and going, it was wrong because you are giving all the values. But this one to indicate, because we have indicated now 7, 6, 5. So it's you are showing that it's and so on and so on. These numbers that I'm indicating are integers: 7, 6, 5, 4. They are integers. So it's a continuation. We are going to have a continuation 3. And so the examiner knows, okay, all these numbers that you are now indicating with an arrow are integers. So you can indicate it at 5. You can indicate it at 1, whatever. You just count any integers of your choice. Then you indicate, all right, my integers, they are from that number. They are from this number, but they are going up to infinity. They do not end. So that is the idea that you're going to have. So this is what we have. But if it is like this, all right, also here, these are any. Remember, any represents natural numbers. And natural numbers, we are talking about values which are greater than 0. All right, these are actually integers greater than 0. 0 is not a natural number, all right? Remember, when I talk about natural numbers, we are not talking about 0. 0 is not involved. 0 is involved when they put n not like this, n is 0 like that. This is for integers where 0 is now involved, okay? When 0 is now involved like this, you have to indicate it. But on natural numbers, 0 is not part of natural numbers. Our natural numbers, the set of natural numbers, it starts from 1. So it's 1, 2, 3, 4, 5, all those positive integers, but 0 is not there. Up to infinity, they do not end. So they gave us these natural numbers, and we know that they start from 1. So instead now of us having something like this at 7, then we indicate an arrow, numbers that are less than 7 like this, and arrow. This is wrong. Why? Because they are natural numbers. We are not talking about all the values that are less than 7. No, they are not all values that are less than 7. Yes, -1 is less than, but it's not a natural number. But if they said integers, it was going to be fine. So now what are you going to, if they said, real numbers, it was going to be fine. But because they said natural numbers, and we know that 0 is not part of natural numbers, so it's going to be 1, 2, 3, 4, 5, 6, 7. 0 is not part of our natural numbers. It's not involved. Natural numbers, they start from 1. So numbers that are less than 7, we are going to start from 1. The first natural number that we have is 1, 2, 3, 4, 5, 6. 7 is not involved. Why? Because they are saying x is less than. It's not less than or equal to. If there is an equal to, you indicate 7 also, but the equal to is not there. So 7 is not part of our solution. So these are the solutions that we are supposed to have on our number line from 1 up to 6. These are the natural numbers that are indicated here. All right, so that's it. That's how we answer this one. Question number 8, x is such that x is greater than or equal to 0, meaning to say 0 is there, but this x represent integers. So z for integers. So if they are integers, it means this is our 0 here, 1, 2, 3, and so on. So I'm just going to indicate maybe this is 1, this is 2, this is 3, this is 4, 5, and so on. So I know that these are integers, and 0 is there because it's less than or equal to. So I'm going to indicate 0, 1, 2, 3. I'm indicating what? Integers. But because there are so many, they're not going to end. They are not going to end. 5, 4, 5, 6, and so on and so on. So I'm just going to indicate these values, they do not end. So I indicate with an arrow. As long you follow this order that I indicated before, it means I'm correct because I'm going to have 6, 7, 8, 9. I'm talking about integers. I circled integers. So the examiner knows that, okay, you are indicating what? Integers. And you're telling us now, these integers, they do not end. They are up to infinity. That's why you indicate with an arrow like that. So you are from the set builder to the number line. So sometimes they give you this number line, they ask you to write the set builder. It can be like that. You just have to be very, very careful on your presentation. All right, let's see. Let's see this part here. I just think it's gonna help us. On top here, let me just try to reduce this, okay? There's this part here. All right, like this part, this is what I'm trying to say. They are asking you to write the set builder in this case. All right, write down the following sets in set builder notation. All right, the first thing that you're supposed to talk about, these are the x values, yes, which is fine. So this is B. Let us start with number 1. So the set builder is the one that you have in terms of a set, the one that you're given before. So you know that x is such that. But what is this x representing? Where is it starting from? 2. Because we are given a starting point and we are given an ending point. We are not given that condition where they indicate, say, these values, they are still going. We are given a starting point from 0 to 4. So you've got a starting point from 0 to 4. From 0 to 4. This is our starting point, 0 to 4. 0 is part of our solution. 4 is also part of our solution. So it means this x is greater than or equal to 0, less than or equal to 4, because it's there, it's involved, it's part of the solution. But what about that x? What is it indicating, this x? What is it representing? Is it representing integers? Is it representing natural numbers? Is it representing? So if in case like this, where you're given 0, 1, the numbers are indicated like this, it means these are integers. Natural numbers, they don't need to indicate like this. They just indicate in between 0 and 4. This is to show, for real numbers. But once they indicate this 0, 1, 2, and so on, these are real numbers that these are integers that we're talking about, all right? Yes, it can be whole numbers and not, because we do not know, but because we do not know all the numbers that are there on this side. So we are going to take our x to be an element of what? Integers. So these are integers, okay? That's how we can have this solution. All right, on item 2, or number 2, I want you to see, they indicated from -6 up to 4 in this format. So we said once they indicate like this, they are saying any number in between can be taken. So it means these x values are no longer integers, they are real numbers, because you're talking about any number as long it does exist. So x is such that with the limits from -6 up to 4. But now let's take a closer look of x. At -6, they indicated with a shaded circle, and they said wherever you see this shaded circle, it means the sign there is supposed to be greater than or equal to, less than or equal. That's where you indicate with what? A shaded circle. So that is x is greater than or equal to. But on 4, it's not shaded. It's just a circle which is not shaded. So you indicate less than. You don't put this equal to, is not there, all right? And like I said, here they're saying every value of x is taken. So it means this x is an element of what? Of all the real numbers. Of all the real numbers. Every number is taken. That is why we are not indicating these on certain numbers. If we are indicating on certain numbers, it means they are integers. We are specifically taking only integers. That was the z. But this one, it's no longer taking like they just say any number, as long it's in between here, it can be taken. All right. So that's the condition. Number 3, all right, x, again, these are real numbers because they're saying all these numbers this side. Where? All that side that you're going. So all those numbers, every number there. So this x is representing what? Real numbers. So x is such that, and as you can see, x values, they are less than 7. So x is less than -7, sorry. It's not shaded, so there's no equal to. We're not going to put any equal to. And this x is a real number, so because it's not given like where to start and where to end, with every number that is involved there. It is the same thing as number 4. Also, we are not like given a specific numbers. So all these numbers are real numbers. Square root of 5 is a real, remember, real numbers, the combination of rational and irrational numbers. So number 4, it was supposed to be x, all right? The set first, all right? So you're gonna have x is such that x is greater than these values on that side. They are greater than 5. They are greater than the square root of 5. But because it is shaded on this number, there's a shaded circle there. So it means it's greater than or equal to. It's also part of the solution. Once it's shaded like this, there's an equal to on -6, but on 4, it's not shaded, so you do not use the equal to. That's the idea there. All right. So which values are we going to take? In this case, all the real numbers. Square root of 5, these are real numbers, all right? So x is an element of what? Real numbers. Okay, this calls you guys for a revision of your types of numbers. Remember, we talked about the type of numbers that we have in our syllabus, all right? We talked about the types of numbers that we have in our syllabus. You're supposed to know all the numbers in your syllabus and how do they ask questions pertaining each and every number that you have. All right, that was it. Number C, represent on a number line. All right, so these numbers are just to be indicated on a number line. When it is like this, all right, it's another format that you can be given. This one, it's another format that you can be given, where they are saying x is such that x is taken from -2 to 7. I want you to be very, very careful on that part. All right. I want you to be very, very careful because in some cases, we are not sure where to start and where to end. All right. You are not even sure when it is like this, because I can indicate X is such that it is from -2 to 7 like this. I can mean numbers direct from -2 to -7, or I can mean from -2 to a number that is less. I can mean it this way: X is greater than or equal to -2, less than or equal to 7. I can mean it this way: X is greater than or equal to -2, but less than 7. X is greater than -2, but less than. So it's not a specific illustration that is clear to you guys. And it's so unfair because of that, because it can be presented in any way. All right. So that's why you see, if you are even using the answers, you see the answer for this one, it has changed. Another one, why are they changed? Is because it can be presented in any manner. So it's up to you. Which manner do you want to present as? Let's say I want to present this as X is greater than or equal to -2, but less than at 7. It means I'm going to start at -2 and at 7. And -2 is part of the solution. It's involved because it's greater than or equal to. But at 7 is just less than, so I'm not going to indicate the 7. I'm just going to draw a shaded circle. Then I join the points in between, just like that. I'm done. So this one is all about you. Is which presentation do you want to present? So it is the same thing as number 2 and number 3. But let's say on number 4 now, or number 5, it's a different scenario that you have even on, okay, number 5 is just one is the same thing again. It's up to you whether you want to share those. You can present it like this, you can present it like this, whatever that you want. It's up to you whether you want to share all of them or you do not want. It's up to you. Okay, so I'm not going to talk about that, but this one is important because here they are saying our X values is taken from -6 up to positive infinity. It means if this is presented like that, it means I have got -6, but to positive infinity, it means these values, they are going up to, they do not end. So you indicate those values with an arrow like that to show these values, they do not end from that number that we are given, which is -6. They do not end. So you just indicate with what? With an arrow. All values that are greater than -6. You see the difference. When it is negative infinity, you indicate going to the negative. All right? That's the idea of the question. So I do not want to waste much time, but as you can see, this is what we have. And this presentation here of the set, here they're saying, right, the following in an interval notation. So the interval notation is this one that we are given. Remember, we have got the set builder notation, the one that we wrote. X is such that that was a set builder. But the interval notation is this one. So this is what I want you to see, that when you are given an interval notation like this one, it's from -7 to 9. Whether -9 is involved, you just indicate the numbers that are there, -7 and 9. That's why I said it's difficult for you to tell how to present this one on a number line from a set builder, because you do not know what was the question before. They just show you the numbers that are there, but you do not know, is it less than or equal, but the numbers should be there. You see this one, it's not shaded at -2. It's shaded at 11. Whether it's not shaded or shaded, the numbers that are presented are the ones that you take from -2 up to where? From -2 up to 11. These are the numbers that you indicate. That's an interval notation. As long -2 is there, 11 is there. So now it's difficult for you to tell, okay, was this 11 greater than or equal to? Was it less than? So when they say represent this back to a number line, it's a confusion back to you students. All right? But this is what you just need to understand, all right? A set builder notation, you present it in the way that you want. You want to present it in terms of shaded circles, then you join. You want to present the same set builder from 0 to 5 in terms of circles, which are not shaded. You want to present from same 0 to 5, from same 0 numbers to 5, this one shaded, and the other one not shaded. It's in your hands. It's up to you. You present the way that you want. All right? But this one is different because now they are indicating the numbers. Where are they starting and where are they ending? All right. When you are given it like this, number 3, from -6 going this side, where are we going? We do not up to infinity, they do not end. So it's up to positive infinity. We have a starting point, which is true. We are starting at -6. But where are we going to end? We are not going to end. It's positive infinity. All right. This side, we do not have a starting point. Where are we starting? We do not know. But where we know, what we know is that we're going to end at 1.5. From this side, we are going to end at 1.5. So it is going to start from negative infinity. We do not know the starting point, but that is what? Negative infinity. Up to where? Up to 1.5. So that's how you present what? An interval notation. An interval notation is different from the presentation of the set builder notation. The set builder notation, you are telling us how the x is given. All right. How is this x given? How is your x given? And also that x, what does it indicate? Does it represent integers or what? You see, so that's a set builder notation. And interval notation, just the numbers that are there are the ones that you indicate whether they are raw numbers, they are natural, they are what. We don't want to know about that. So these are different presentations of your numbers, and you need to know this in your syllabus. All right. So we shall come back again, guys, with questions from past exam papers, so that we see how do they ask these questions, so that you be able to prepare yourselves for the exams ahead of time. Just make sure that you prepare as much as you can, do as much question papers as you can. You'll be able to prepare yourselves for the exams ahead of time.